Hey guys, this is Mr. Yo, and today what we're going to talk about is ionic compound nomenclature. So first thing first, before we even begin, one thing I want to make sure is that the word nomenclature. A lot of you guys probably don't know what that means, but if you take Latin, it should give you some knowledge of what it might be called as. This is also called, basically, name. So what we're going to talk about is more like how do we exactly name a compound? Just like if we see any chemical formula, what is their specific name for it? That's what we're going to learn today. So without further ado, let us begin. Before we even start anything in general, we need to know the charges because not only that we need to know the name of the chemical formula, we need to also figure out the vice versa, figuring out the chemical formula. So, the first column is called +1. Second column +2. 13th column +3. Plus and minus 4. -3, -2, -1, and 0. So make sure you guys have this note down because this is very important and very needed for this lesson. Also, just a quick heads up. Now, group 14, I know it says plus and minus 4. We don't actually use that column as much. So if you are worried about which charge number would it be in that specific column, don't worry about it. Okay? All right. So, a couple notes that we need to know before we even talk about ionic compound is the difference between ionic and covalent compounds. Ionic talks about transfers electron from positive to negative charge. So the key word of ionic compound is transfer. Now, the positive charge is the metal. Okay, you guys probably know that back if we go back to the periodic table, is that everything that's on this side right here, okay, these are all positive charges. So you should know that looking at the periodic table, left side is always positive. On the other hand, we have the negative charge, which refers to the nonmetal. So back in the periodic table, anything that's on the right side of the periodic table are negative charges. So make sure you have that down before we move on. Now, on the other hand, covalent compounds. These are basically a nonmetal shares electrons with another nonmetal. So it's very important you know the difference between ionic and covalent, even though we're going to talk more about ionic compound for this unit. So make sure you guys have this down before I move to the next slide. Okay. So how do we actually name an ionic compound? Well, it's pretty simple. You got to follow these 3 steps. Number 1, find a metal or a cation and a nonmetal or an anion. If you don't remember what a cation and anions are, well, cat, paw, positive. So it's a positive charge. Anion, onion, you feel negative feeling, so it's negative charge. Number 2, place an IDE ending on the nonmetal. So IDE, nonmetal. Very important, very crucial for this lesson. And last but not least, put them together. So without further ado, let's actually go over and try out some examples. So remember, our first deal is to find the metal. So right now, our cation is the Na, which is sodium. For our anion, on the other hand, is the Cl, which is chlorine. But remember, our ending for our nonmetal must have the IDE ending. So what should we do? Well, what we can do is technically take out the INE part, this section right here, and replace it with the word IDE. That's usually the easiest way to do it. Other than that, I highly recommend that you sound it out and try to see if that sound more fluent. If it doesn't, then probably that's not the right anion. So make sure you guys have this down before I move to the next part. So in the end, our answer for this one is sodium chloride. That is our final answer. And that's probably something you guys already have known ever since before chemistry, before you guys even taken chemistry. Probably from someone else, or probably from, I don't know, from middle school science or so. All right. Let's try some example problems. So if you guys want to pause the video, make sure you look at your periodic table to figure out this name. So pause the video and try it out on your own. All right, so let's see. Ba in the periodic table is barium. Cl, on the other hand, well, that's chlorine. But remember, we have to take that INE and replace it with IDE. So our final answer is barium chloride. There you go. Next one. Try this one out as well. Pause the video, and I'll reveal the answer in a bit. All right, so Na is sodium. O is oxygen. Now, this might sound a little bit weird. Oxygen. If we place the IDE, it's going to sound like oxygenide, which doesn't actually sound as professional or more fluent in a way. This one is actually translated into oxide. So it's sodium oxide. There are some elements that may not have an INE and replace it with an IDE that easily. So make sure you guys try out by plugging it in, sounding it out, whatever you guys have to do. Okay? Let's move on to the next one. So now that we know how to name things, why don't we learn the opposite, which is figuring out the chemical formula. So here are some following rules that you need to follow. Number 1, find the element symbol and charge. So this is where that charge review that we did previously comes into play. Number 2, crisscross the number as subscripts. So the numbers I'm talking about are the charges. So I'm talking about basically the charge. But I'll explain more about why I said just a number, not any sign, not writing the word charge. But before I do so, there are some rules that you also have to remember. Number 1, make sure the metals goes first before the non-metal. Just like how we named it, we had the metal first and then the non-metal. Chemical formula, it has the same rule as well. Next, simplify the subscript as much as possible. This is more like in math class, we always simplify our answer, just like fractions and some other stuff. And I'll explain more about that in our example question. So make sure you have the notes before I move on to the next part. Okay, so calcium. What is calcium? Well, what's the symbol for calcium? Calcium is Ca. Let me actually write this bigger. Ca. Then what is chlorine? Well, actually, before that, what's the charge for calcium in the periodic table? Well, since it's in the second column, it's going to be +2 charge. Chlorine, on the other hand, well, we know that's Cl because we have been solving or using that element quite a while. And what's the charge of that? Well, if you guys remember, chlorine is actually in group 17 or column 17, which has a -1 charge. So that's step number 1. Step number 2 is all about that crisscross applesauce. So when I say the number, I'm specifically talking about these numbers. And we're going to crisscross it. Just like that. Now, remember, when we crisscross it though, just a number, the charges will disappear. So in the end, our answer will look like Ca1, Cl2. Now, if you guys don't remember what these are or what these numbers represent, these are subscripts. Now, what are subscripts? It tells you the amount of an element. So, for example, if we have a 1 behind calcium, then that means calcium, oops, maybe that's too much. Calcium, there's only 1 calcium here. Then how about the 2 here? Well, that means chlorine has 2 in this compound. And there you go. So make sure you guys understand that these numbers now becomes subscripts, not charges, but subscripts. Now, another thing I want to mention is this. If you have a 1 here, and in math class, you guys probably heard of 1x. That's the same thing as x, which means what I'm trying to tell you is that you don't have to put that 1 as your answer. So normally in chemistry, we would write it as CaCl2. And there you go. I know that was quite a lot, but make sure if you guys don't understand it, rewind and try to look over this one more time in order for you to understand it more. Okay? Let's go and try out some practice problems. So pause the video before I reveal the answer. Okay, so barium. Barium is Ba. It has a +2 charge. Nitride is N with -3 charge. If we crisscross applesauce, our answer is Ba, 3, and 2. There you go. Simple. Next one. Try this out, pause the video, and I'll reveal the answer as well in a bit. Okay. Calcium is +2. oxygen is -2. Now, if we crisscross it, our answer will be Ca2O2. But remember, there was that one rule that we said we must simplify. So in this case right now, we see that there are two 2's. Technically, we can simplify this out by dividing it by 2 on both sides. Now, if we do that, our final answer is just going to be CaO. So make sure that you check out the numbers, the subscripts, and see if you guys can simplify it or not. All right. Well, that is basically how you figure out the chemical formula. But there are stuff that you do have to memorize, which is called the polyatomic ion. Now, what are they? Well, polyatomic ions, poly, if you guys don't know what poly means, it's basically like more than two, more than 2 or 3 or so on. But polyatomic ions, so there's more atoms in this compound. So ions that are made up of more than one element that are covalently bonded together. So remember, covalently means shared. And if it means shared, that means it doesn't want to separate from one another. This is very important to know, okay? Because later on, I'll show you why it's very important. So first of all, we have OH minus 1. If you don't have any numbers in front or right behind the minus or a plus sign, that basically means that there's an invisible 1. So don't worry about not knowing that. So OH has a -1 charge. It's called hydroxide. Remember, hydroxide, not hydride, hydroxide. I'm emphasizing this because a lot of you guys will think that hydroxide is just H, and it's not. NO3 -1 charge is called nitrate. Sulfate, SO4 2- or -2. Carbonate, CO3 -2. Phosphate, PO4 -3. Chlorate, ClO3 -1. And ammonium, NH4 +1. Now, sometimes we call this as this. So if you guys want to kind of read the symbols in this order, you should hear this phrase. Oh no, so co, po clo no. Sounds a bit strange, I know. But that is also another way that you can remember it. Every single chemistry teacher will probably teach you that method. Or maybe some. Now, if you guys are stuck, well, also another way that you can remember this is N. We already know N is a nitrogen. And also, the only thing that is different is that ATE ending. Same goes with sulfur. S is sulfur, and we have ATE. Carbon, ATE. Phosphorus, ATE. Chlorine, ATE. So those 5 specific ones are easy to figure out, but the rest, hydroxide and ammonium, that's just something you have to memorize. So if you guys want, you guys can definitely double check from any other sources. If there's any other easier way to remember the polyatomic ion, go for it. Other than that, I would say use a index card or anything that can help you remember or memorize these parts. Now, if you're in honors, there's going to be probably more than 20 plus polyatomic ions that you need to remember, which I am not going to cover in this lesson. Now, a note that I want to mention is this. Parentheses must be around the polyatomic ion when creating a chemical formula. Well, this is the part where that covalently bond comes into play. So let me actually show you what I mean. We know barium is Ba with a +2 charge. Hydroxide, OH with a -1. The first thing what I would do if I were you is put a parentheses over the OH. Okay? Or if it was sulfate, SO4. If it was nitrate, NO3. So any subscripts that you see on the bottom also must be included in the parentheses. The only thing that's not included are the charges. So if we crisscross the numbers, your answer will become Ba, parentheses OH, close parentheses, 2. So remember to put parentheses over OH or over polyatomic ions. There's a big difference. If you want to know, OH2. This means that there's 2 of OHs versus OH2. This means we have an oxygen and 2 hydrogen. So this is the reason why it makes a big difference between those two. So please, 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 polyatomic ion, you must put parentheses over them and then put the subscripts down. Okay? All right. So that is the basics of the nomenclature. Now, something I want to go over more are the following. But before that, try this one out. And we will go over the transition metal section. Okay. So this one, we have potassium, which is K plus 1. OH is -1. Crisscross it. You can either put it as KOH or K parentheses OH. Now, in chemistry or in chemists, do not put parentheses over things that have just one. But your choice. I personally do not mind, but you can talk with your chemistry teachers to see if they allow that or not. Next one. Try this on your own, and I'll reveal the answer. Okay. Well, remember, this is phosphide, not phosphate. So if we crisscross it, SR3, P2. Bam. Okay. Now, here's the note for the transition metal. It's pretty much the same thing as what we have done previously. But the only thing that is different is the Roman numeral. So number 1 says, same process as ionic compounds, cations and anions with IDE ending. But number 2 says, figure out the charge of the transition metal and convert into Roman numerals. I'll talk about the Roman numerals if you don't know what those are. And there are some special cases, which are zinc has +2 charge, silver has +1 charge, and they don't have a Roman numeral even though they're transition metals. Those are the special cases, technically. And there's also more, which I can tell you right now. SN and PB, so tin and lead, have Roman numerals. Now, these they're not transition metals. They're called post-transition metals. However, those are the special cases. Even though they're not in the transition metal section, these two will have charges. Now, some teachers probably might teach you guys more exceptions, but this is all I'm going to mention for now. Okay, so let's go over it. So if you don't know the Roman numeral, make sure you guys copy the chart that you see on the left side. So number 1, let's figure out what Fe is. Well, we already know Fe is iron. Cl is chlorine, or to be more specific, chloride. Now, in order for us to figure out the charges, this is very important. Always look for the nonmetal section first. So always look for this first, because we already know the charge for those. So chlorine is -1, which originally came from right here. So if we know Cl is -1, then this 3 right here is the charge for iron, which means the Roman numeral III. There you go. So make sure you guys rewind and make sure you understand how this is done. If you still don't get it, please look it over. And if you do get it, try this example question out. Okay, well, let's reveal the answer. So Hg, that is mercury. O is oxide. We already know oxygen has a -2 charge, which actually makes sense. And we have an invisible 1 here, which means mercury in this case has a +1 charge and a Roman numeral 1. There you go. Now for the next one is a little bit tricky. But before that, make sure you guys have this down and understand what just happened. Okay, this one's a little bit tricky, but if you guys can try it out and pause the video. All right, so the reason why it's tricky is we already know it's mercury and we already know it's oxide. That we already know. Now, you know that oxygen is -2. But how come this side doesn't have a 2 there? Well, here's the reason why. Remember that when we draw or write down a chemical formula, we always simplified. What's going to happen now is we're unsimplifying it. For example, if we know this is a 1 right now, and we want to make it into a 2, we must multiply this by 2 to get its original charge. Now, if we do it on one side, we also have to do it on the other side, which in this case, we also have a 1. And this will give you a 2, which means +2 charge. So Roman numeral 2 for this mercury. So as you guys can see, transition metal has so many charges. It can be 1, 2, 3, 4, 5, 6, 7, so on. So make sure if you want to find the charge of the transition metal, you look at the problem, not the periodic table for the transition metal. Okay? Now let's try the vice versa way. Now this is way easier than what we just did because the charges are actually provided within the problem. So I'm not going to go over too much about this because this is pretty much the same thing as the previous one. So number 1, I'm going to write down our symbol and our charge. Symbol, charge. Last but not least, crisscross applesauce. And that's how we get the answer. Pretty simple. Try these questions out on your own before I reveal the answer. Okay, well, Chromium. Now this is a +6. Vi is 6. Fluorine is -1. Crisscross applesauce. Get CrF6. There you go. Let's try another one. Gallium, +3 charge. Nitride, -3. Crisscross applesauce. Ga3N3. But remember, these can simplify. So we're going to divide 3 on both sides to get GAN. If you guys have any questions, please make sure, first of all, review the whole video and then ask the question. If not, and if you guys are good to go, awesome. So make sure, review, review, review. That's all I'm going to say. This is a pretty easy concept, but it can be tricky depending on how much small mistake that you make, especially in the IDE or the ATE that we talked about previously on polyatomic ions. So good luck. And if you guys have any questions, please let me know. And hope you guys have a wonderful day today.